Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. Sorry, text going off. Today I'm going to be going over how to take a output board that you can obviously separate from the power supply and test the functionality of this before really proceeding with loading up all your output transistors. As you can see right over here off to the side, I have all the 20 and 50s ready to go in. This is a Z2C output section from Digital Designs. So as you can see here, Digital Design. So this is Z2C, and I always like to make sure that my drive is okay before I put transistors in. These vias are robust but sensitive at the same time. So anytime you have a failure with these output boards, a lot of current goes through these vias and it just destroys these things. So the more you have to take out transistors and put transistors in after failures, the more you're going to start to lose the vias that go to the bottom side of the board. And it'll take someone, a lot of time to repair the vias, as I did. It's kind of off the side here, as I did right over here. This whole bank I had to repair all the drains because it literally took all the vias out with it. This will be set number, oh gosh, we're probably set number 4. I could be even set number 5 in this amp. But I'm going to show you how we're going to hook this board up and test the drive and see if the output section is still functional and switching right. And how I do this is I use an external power supply. Let me see if I can pull this out without getting too much stuff in the way of cameras. Yes, I use another amplifier. Just its power supply though. Few modifications here, a few modifications there, and you can make this run a, what is this, oh gosh, I don't even know what size. This is probably like an 11K or 17K, 16K amplifier. So yeah, a little Maxonics board is going to run the output section of this. So really all you need is just a couple voltages present to make this happen. You got screws. These are the screws, M5s, that are in speaker terminals, which will screw right into the tabs of the output board here. So I'm just going to put my screws in here. And yep, we only need 3 of these. Technically, you only really need 2. But I like to have a third here. Why? I don't know. But I do believe that this will fire all up without me hooking up a common here. I like to have this available when I'm testing the output sine wave on these. So I got the screws in, and then I have my little wires here, my little bundle of joy here. This is it. This is all it takes. Little wire. This is probably 18 gauge wire. So I'm going to hook up positive rail. So it's going to go positive rail, negative rail, common. I need an AC signal here, and I need a common connection here because this is referenced to negative rail. The voltage regulator is referenced to negative rail. So we need a common for that regulator. So I'm just hooking up my wires here. So that's my positive rail. Give me a little bit more room here. This is my negative rail. I'm trying to do this, of course, with very limited room on my bench. There's negative rail, and then I have my common. And there's my common. So now we need 2 more things. You need an AC signal, or you can supply its own plus minus 15 volts. I wish I could go a little wider, but this camera here doesn't go wider. but you guys can kind of see it on this big screen here, how I have it set up, kind of. I don't know if you have to zoom in on that little picture there, but the output section of these has a plus minus 15, plus minus 12, plus minus, who knows what it may be. Some are 15 volt regulators, some are 12 volt regulators. And then you have a 12 volt regulator. These are all 12 volts. And then you have a 12 volt regulator here. That's referenced to negative rail. Sorry guys. Let me see if I can get the camera over here. Hey, look at that. So this one here is referenced to negative rail. This one here, these two here are your plus minus 15 volts. This needs an AC signal. This needs to be referenced to common. Let me get this set back up. Maybe. Okay, so we need an AC signal, which I have my AC signal here with my yellow wire. Just a little header pin here, and I'm going to hook it right up to this header pin. So there's my AC signal, and then I need my common, which I have over here, which is my blue wire. Another header pin, and I just slide this right onto the wire. Oh, hold on. I got to remember too, this is the Z2C. Why do I mention something like that? Well, because they throw, I think, if I remember right, they threw a little loophole here. Not a loophole. Hold on. Okay, I was just double checking and making sure. Sometimes they change the pin out. Oh no, it's right. Okay, it is the first pin. Whew. Never mind. Yeah, so first pin. Some amps, you have to check your continuity, which pin it is. A lot of these boards are the same, so it's the outside pins. So my common pin here is the outside pin, and then my AC pin is the outside pin. You know, just simply just checking continuity, just to verify that I'm sending my voltage to the right place. Because what you don't want to do is you don't want to destroy anything that's working. So this sets us up to test the output section here. Now these boards, if I remember right, do they not? I can't remember. Well, let me get the scope fired up. I haven't even started the scope for the day. Been a little busy on the phone, and a lot of shipping. I got a lot of shipping I got to take care of. And I have a schedule that I have to meet today. So, scope is starting. My primary goal for this task is to see that I have low side drive. That's all I'm looking for. If you have low side drive, then you have a good drive. It's 95% okay to put your output transistors in. So I am going to, I think I need an input signal for the MIC based output sections. I do believe you need an input signal, but I'm just going to double check. I may not need it. So I'm just going to hold on. It shouldn't get too hot because I don't have any transistors in. But I always have a little clip here with a thermal pad and a heat sink, because your voltage regulator for the one that's referenced negative rail is going to get warm. Pretty warm. Extremely warm. And these regulators will cut out. Are they like an amp or 1.2 amps? Which makes them sometimes real hard to test these with the transistors in, depending on what kind of supply you're using. Because if the voltage drops too low or the current gets too high on the regulator, it shuts off, and then the drive shuts off, and you'll see this thing just turn on and off, on and off, on and off, on and off. So Let me go ahead and fire up the power supply here. All right, hold on. Okay, I was just making sure that my voltages were okay. Let's go ahead and fire this up. This should be okay. You're not going to hear any relays click in. All right, so there's no, that's what I thought. So I figured you need an input signal for the the MIC based amplifiers. So I'm going to go ahead and plug in the RCA jack. Get my signal here, which everyone knows that watches my channel. I do use a 50 hertz input signal to test from the signal generator, my good old Heathkit 1272. So let's go ahead and see what this thing decides to do for me today. It's going to decide to do nothing because I probably, yeah. No. I done broke it. Oh. Hmm. Well, it looks like I might have broke my, shoot. Yeah, it looks like I might have I've got my signal going to the card. But I may have. Yeah, all right. I'll be right back. All right, I am back. I had found a glitch from the last set of transistors. I think it took out the drivers. Because when this would start up, I would not get a square wave on pin 1. So that's one of the first things I look for is a square wave on pin 1 of the 2184 IC on this driver card. This is an SNI board, so you're going to have an IRS 2184 IC that drives some MIC 4452 gate drivers. So that is what we have going on there. Let me just bump my power here real quick. Much better. All right, now we're back in business. Oh, well, you guys don't have a scope on your Hey, don't worry. Sometimes I'm not good at multitasking, so let me just get your guys' scope up here. Words usually don't mean much if you can't see what's going on, so we're just going to go ahead and fire up the old Rigol scope there. All right, there's the scope for you guys. So back to what I was doing before I found that it did have a shorted drive up gate driver. So I was using a test set of transistors. I was trying to find a different set of transistors that had a higher voltage rating for this, but I just I have too much time into this, so I did not find a compatible transistor. But the last set that I used did take out one of these drivers. You may start to see my camera glitch every time I fire up my scope. The camera starts glitching out like that. But what I'm looking for with no transistors in the circuit is I'm looking for low side gate drive. So let me fire up my power supply right here. Yeah, a little slight relay click there because the relay is still active. But there's the low side gate drive. So there's one side of the amplifier. And there's the other side of the amplifier. And that's what I'm looking for when it comes to the SI or the MIC 4452 based output boards, is I'm looking for this low side square drive right there. That's what I'm looking for. Excuse me. And as long as I see that on both sides, then I know 95% of the time that I'm going to be good to go. That is not, though, telling you the condition of the high side, which is a floating high side, so it's bootstrapped. But more often than not, I don't find issues there. So usually you have output failure. The output failure takes out any Zehners. The Zehners fail. The drivers fail. Let's come right on over here and show you guys. The drivers fail at the card, and then sometimes, rarely, sometimes, the IRS 2184 IC will be damaged. I've had some preamp issues where it has damaged the 072 on it, but that, again, that's a very rare situation. But otherwise, this is still running, still has low side gate drive on both halves of the amplifier. So this is a half bridge amplifier. It's got two half bridge sides that are paralleled. So I've been seeing a lot of that floating around as people are confusing what a full bridge and a half bridge is when it comes to strapping. I'm not a fan of strapping amps though, guys. So probably not the guy to talk to about strapping. Don't strap. Unless you want some pretty hefty repair bills. Yeah. This is a half bridge gate driver. So, and realistically, bottom line, this is a half bridge amp. IC. Designed though, they parallel to half bridge. That's why I'm looking for both sides. So and then of course I said the voltage regulator does heat up. There's no transistors installed. So this voltage regulator doesn't have to work very hard right now. But if you put transistors in, boy, this regulator will heat up. And I'm finding this to be somewhat of an odd balance with the amplifiers. This starts to heat up, and you only got an amp or so of available current through that single regulator. But what is that regulator driving? Not only is it going to the card, but it's also supplying the drivers. So it is directly seeing the demand of the output transistors. Just something to keep in mind as these things heat up. I would much rather see two of these in parallel over here, which you'll see on some amplifiers. Why does this have one? I don't know. That's just my opinion, though. All my statements are my thoughts and my opinions, only from what I see every day. But this amplifier is up and running. Oh, it is snowing like crazy out there today. Woohoo! And my daughter started driver's ed. Nice. So that's that, guys. I just wanted to show you. Let's go back over here. I have a power supply that I fabricated. Again, this is just showing you what I am doing to power up this board. If you are not familiar with electricity, current, and all that, please don't do this. If you're not familiar with electricity, I am a retired, I like to call myself a medically retired electrician. Electricity and current is just something you don't play around with if you're not familiar with it. This is just half of this amplifier, but if this amp was together and charged up, I don't even know how many capacitors there are in this. There's, I just counted, there's 28 1500 microfarad capacitors, rail capacitors for this amplifier. Just to give you an idea of available current, 28 capacitors stored energy versus 2. So that's where I always say, always at the end of my videos, guys, stay safe out there. Keep your fingers out of the rails. I would not want to see anyone, you know, get hurt from electricity in this world. I've seen that way too many times. So that's what I wanted to show you guys, what I do to power this up to verify its functionality before giving it all 200 volts and, you know, causing severe damage if there was a short. I like to find my issues before I power them up. But that's where I want to show you. So guys, stay safe out there. Thanks for watching. If you have any comments, please leave them down below and I'll get to you guys as soon as I can. And affiliate links too down below. So if you have any questions about the products that I use, they are down below. And we'll see you guys on the next one. Again, keep your fingers safe out of these rails. Thanks a lot. Catch you on the next one.